Hi St. Lawrence, and welcome to our third STEM day of the year. Today's focus will be physical science. We will be completing a phase change challenge. But the first thing we need is to be safe. All right. The next thing you will need is to make sure that you print your activity guide that I provided for you for today's STEM activity. You will be answering the challenge. Which method will melt the ice cube the fastest? You will first need to think about how are you going to melt the ice cube. Without adding anything to your ice cube or taking your ice cube out of the bag, which method will melt the ice cube the fastest? Go ahead and press pause, think about your hypothesis, and record it now. Once you've done your hypothesis, we're going to go over the materials you will need for today's activity. You will need 2 ice cubes straight from the freezer of the same size. You will need 2 Ziploc bags. You will need a marker to mark your plastic bags, your activity guide, as well as a timer or a stopwatch. Today I'll just be using my phone. Okay, the first thing you will do is to mark one of your bags the control. So you see that I've already written control on my bag. This is an ice cube that will just be left alone. Once we place it into the bag, we will leave it alone. You can decide to do this activity inside or outside, in the shade or in the sun. But wherever you decide to melt your ice cube, you will also be leaving your control. So today I'm just going to put my control over to the side of my table and let it melt. When I start the timer, both ice cubes will be melting at the same rate. Okay? Our second bag will be marked method. This is the method that you choose. You could also write trial 1, trial A, but this is the one that we are going to be manipulating. Okay, so we place our ice cube that has been out of the freezer for the same amount of time as our control, place that one in our second plastic bag. Okay, then you are going to choose the method, any method of your choice, to melt the ice cube. Come back after you've melted your ice cube, make sure that you record your time, and we will work through our results together. All right, once your ice cubes are completely melted and are not visible at all in your bag, you will stop the timer. For my method, I melted the ice cube in 2 minutes and 45 seconds. For my control, it melted in 24 minutes and 57 seconds. So what I'm going to do is I'm going to record my time in my data table. So 24 minutes and 57 seconds for my control, and 2 minutes and 45 seconds for my method ice cube. And you will see that in the method, in the data table, there's a place for you to describe what method you chose. How did you melt your ice cube? I melted my ice cube by rubbing the ice cube together in my hands until it was completely melted, and that took about 2 minutes and 45 seconds. Did you do the same thing? Did you run it under hot water? Did you rub it around on the warm ground outside in the sun? How did you melt your ice cube? Leave a comment with how you melted your ice cube and the results you got to see if we can compare what everybody's different methods were and which one melted the ice cube the fastest. After you record your time, you're going to answer the question that's at the bottom of the first page. Were you successful in melting the ice cube? Probably yes, but to what degree? Did it not melt as quickly as you thought it was going to? Or did it melt faster than you thought it was going to? What results did you get? You can record them at the bottom of your paper. If you look on the second page, it says Connection to Physical Science. We are again talking about the physical science of phase change, right? The states of matter. We are going to answer our conclusion questions. Melting of ice. What type of change is melting of ice? It is a physical change. Melting of ice is a physical change. It is not a chemical change. It is a physical change. Going from a solid to a liquid is a change of state, right? It's the states of matter, but it's going from a solid to a liquid. It is a physical change. What are the 3 states of matter? You probably know this, but let's go ahead and review, right? What are the 3 states of matter? We have solid, thank you. We have liquid, and we have gas. Yes, very good. Okay, so the 3 states of matter, solid, liquid, and gas. Now, we today were working with solid and liquid water. right? Water is unusual and it's unique and it's so important for life for one of the reasons is the fact that water exists as a liquid, a solid, and a gas naturally on our Earth in all three states of matter. Solid in our ice caps or any frozen sea ice or in our mountains. We have liquid water, of course, in our seas and our freshwater systems. And we have gas, water vapor, all around us all the time. So these are the three states of matter. Now, solid water, right, exists as cubes or chunks, right? Now, what is the difference between these three states of matter? Okay, so I drew my three states of matter. We have solid form, we have liquid form, and we have gas form. But what really is the distinguishing characteristic between these three different states of matter? If you look at it at the particle level, where the molecules and the atoms are, there is a difference in how those molecules, particles, and atoms act. In a solid, all those particles are very close together, right? All those particles are very close together. They have a very rigid shape, okay, a fixed shape, and a fixed volume. A liquid, however, has more space between the molecules and the atoms. They're more freely moving, if you will, right? They can move back and forth from one another, but there's still a fixed volume in a liquid, right? If you have 1 cup of water in a glass and you pour it onto the ground, you still have 1 cup of water, it's just in a different shape. Whereas a gas, the particles are very far apart and moving very, very quickly. Okay? Water vapor is all around us all the time. Now, how does water vapor get into the atmosphere? Well, if you were to open your bag and dump the water on the ground on a nice sunny day, what happens to that water? It evaporates into the atmosphere. That is how water vapor gets into the atmosphere. That's one way. How else does water vapor get into the atmosphere? When you breathe out, not only do you breathe out carbon dioxide, but you also breathe out water vapor. Plants also breathe out water vapor during the process of photosynthesis. So all life on Earth contributes to adding water vapor to the atmosphere. What happens to that water vapor in the atmosphere? Well, if the conditions are right, that water vapor will condense into a liquid, right? We have clouds and precipitation will occur when the liquid falls from the sky. So solids, liquids, and gases, these phase changes, the states of matter, are very important for all aspects of our life. Not only is water essential for life, but the water cycle that is driven by these different phase changes is also essential for life. So you're going to go ahead and answer this question. The third question down there at the bottom is if you were to do this again, how would you change your method? Go ahead and try. Choose a different method. Melt the ice cube. See if your time compares to the first one. Well, I hope you've enjoyed our third STEM Day challenge. Please leave a comment with the method that you chose and the time you got for melting your ice cube so we can compare all of our results. I hope you have a wonderful day. Thank you so much for joining me.